Actually, I decided to do one more example in the flexure section of this course. And what we'll do is one more example, slab and T-beam. Here's a simplified problem. Two 20-foot spans, simply supported and continuous. And the beams are 10 feet apart. We're going to design those beams and the slab. Okay, so design the slab, design the beam, and we are using our typical 4 KSI and 60 KSI combination. The solution, excuse me, outline for the slab is to estimate the thickness, compute the moments for a unit width of 1 foot, compute the MN required, get the calculated steel. It may or may not be less than AS min. I've got some pretty heavy loads on this slab, and select the steel and verify that phi MN is greater than MU. And these large loads, these loads are actually pretty large. Let me try that again. There we go. Have a live load of 150 PSF and a dead load of 175 PSF. That's huge. Okay, and to be honest, those are made high so that the slab steel will be above the minimum. The first step is to pick the slab thickness, and this slab is continuous. I'm picking L/28. We need to get this clear span here, but we know the center to center is 10 feet, so we're going to have to guess the width of these beams. And I'm just guessing, since their span, the beams are spanning 20 feet, I'm just going to guess that they're 2 feet deep and that the width is half of that, or 12 inches. So I'm guessing that this is 12 inches and that's 12 inches, which makes the clear span 9 feet. Ln is 9 feet. And the minimum thickness I'm going to use is L/28. So 9 feet divided by 28 is 3.8 inches. And I'm going to pick a slab thickness of 4 inches right here. 4 inches. Now that we have the slab thickness, we can calculate its self-weight. It's 4/12 of a foot deep, or 1/3 of a foot, and 1/3 of 150 pounds per cubic foot. The unit weight of reinforced concrete is 50 PSF. Thus, the total dead load was the applied 175 plus an extra 50 due to the self-weight, and the live was 150, so that's live, and dead, and you factor it, 1.2, 1.6, and you get this 510 PSF right there. The negative moment, here are the ACI moments. It's less than 10 feet, so we can use the slab moments. WL squared over 12 and WL squared over 14, so 0.5109 squared over 12. 3.4 kip feet negative, and 2.95 foot kips positive. And then we're going to get the steel. We've done this many times. You get the MU over phi, and I convert it to inch kips. 49.9 inch kips for the negative, 39.3 positive. You get MN over BD squared. Remember, B is 12 inches, and the slab was 4 inches thick, which makes D 3 inches. And I've had a few people questioning where that comes from. Let's say you have a number 4 bar, there's no stirrups in slabs, and the cover for slabs, you're allowed to have as little as 3/4 inch cover. And the radius of a number 4 bar is a 1/4 inch. And so that makes this distance 1 inch. So h minus 1 inch is d. Back to this, if you take 49.5 divided by 12 times 3 squared, you get 0.425 ksi. And for the negative moment, you get 0.364 ksi. I have that Rn rho equation in my calculator. It numerically solves it. And I get these small rhos. And AS is rho times BD. And remember, we just talked about this. B is 12 and D is 3. And you get this much inch squared. And remember, this is per foot. Positive that much. Let's check the minimum. Remember, for slabs, it's this weird equation here. For grade 60, 0.0018 times B is 12. And this is what's strange about AS min for slabs. We use H, not D. This also is the temp steel, temp and shrinkage steel that will put transverse to the long steel in the slab. Okay, let me make that a little nicer for when I PDF this. There we go. And we are looking for, the numbers we're looking for are, let me write it here, 0.273 for the negative moment, 0.232 for the positive moment, and 0.086 for the temp steel. Okay, go to the table. I guess I could have used this 2.7 for the 273, but I picked that. So that's for negative moment. This is the next biggest one for positive moment. And this is, I decided to use number 3s for the temperature steel. I think it'll be clear enough that the steel going across the beams, you're going to be number 4s, and the steel in the slab going with the beams will be number 3s. And this is the, so this will be the temp steel. Okay. And the final picks I made were, oh, and then you need to make sure that the spacing is less than 18 inches or 3 of the slab thicknesses. And the slab was 4 inches thick, so it needs to be less than 12 inches. And that was this. This is 3H. So everything had to be above that line. So that's why I couldn't pick this. That's why I went with the number 3s at 12 inches for the temp steel. Okay. And these were the final choices I made. The slab's done, and so now we're going to design for the T-beam next.